This is continuation of our previous video. In this video, we'll see network address translation, NAT basics, guidelines for NAT, hide NAT, static NAT, and we'll verify policy and translation logs. In translation, first of all, we should know why do we need a translation? Why use NAT? Now, in IPv4, we have a limited number of IP addresses. Each host within an IP network is assigned a unique IP address that identifies it, correct? But NAT allows a private IP networks to connect to the internet. Without NAT, as you can see in a picture over here, this is my private IP, tries to go from inside to outside, won't get an access through an ISP to our destination. Why? Because your source IP is in a private source. So when source is with the private, will not be able to get internet access until it gets translated to any public IP. So the first thing you have to do is to translate your private into a public IP. Network address translations are of mainly two types. You can separate or you can divide the translations in two types. One as a dynamic, that we call it as a hide, another as a static. Under the dynamic, we have a NAT and we have a PAT. Again, in a static, we have a NAT and we have a PAT. Now, the dynamic NAT and the dynamic PAT, where it should be used, where the static translation should be used, that we need to understand. See, all these translations can be applied either for the source or can be applied for a destination. So whenever you see a translation, first of all, you should separate the translation belongs to a source NAT or a destination NAT, right? If it is a source NAT, mainly we use a dynamic translations. If it is a destination translation, we use a static translations. Depends. Even in a source NAT, there can be a static, but it depends the scenario based where exactly the translation should be applied. Now let's talk about the dynamic NAT. In a dynamic NAT, multiple private IP addresses are mapped to a pool of public IP addresses. Like here you can see we have a private IPs over here. Like we have a 4 private IPs and we have the 4 public IPs in a pool. So equal number of addresses can be translated if we go for a dynamic NAT. Means if we are going for a NAT, NAT is like one-to-one translation, but done dynamically within a pool. So here you can see 192.168.1.1 getting translated to this IP, but that can be changed depending on the availability of the IP addresses in a pool. So if I have 4 private IP addresses and 4 public addresses, it can translate up to 4 private addresses only. If the fifth address tries to go outside, won't be able to go outside because the pool is exhausted over here. So always understand equal number of private and public addresses defined. Translation is done dynamically on first come first serve basis. Usually applied from inside to outside, or you can say LAN to WAN. It's a unidirectional communication. So whenever you see a translation, always understand translations are unidirectional. Means when you see a dynamic translation, not all the translations, static translations are bidirectional. Whenever you see a dynamic translations are unidirectional. It can be used to go from one side to other side, but the request packet can't be initiated from the other side. So it's always a unidirectional, not a bidirectional. Your firewall maintains an accelerate table for the translation records. So I believe you guys understood what's basically a dynamic NAT or a hide NAT. Dynamic NAT is all about one-to-one translation. If I have 100 users, I need 100 public IPs, which is not actually good, which is not the way of saving our public IPs. In IPv4, we need to save our public IPs. But if you use a dynamic NAT, it's really not a way to save our public IPs. So the solution for saving and public IPs are going for a dynamic PAT. In a dynamic PAT, what happens? A group of private IP addresses map to a single public IP address with the dynamic ports. Means we'll have a multiple ports available. So one single public IP can be used to translate the multiple private IP addresses with the dynamic ports. So every time when the user will initiate the connection from your LAN to WAN, it will get dynamically translated with the dynamic ports. All right. Now, there are 64K private addresses that can be translated to a single public IP address with the different port numbers. So now how do we say like it's a 64K port numbers can be used or 64K private addresses can be translated? Well, we have an option over here. So the total port numbers are 0 to 65,535. Within that, 0 to 1023 ports are not used in a translation. Right. Now, the ports available from 1024 to 65,535 are used for translations, but excluding standard port numbers. So we have some standard port numbers like we can have a radius port numbers, we can have a web proxy port numbers. There are many port numbers which comes between 1024 to 65,535. So those standard port numbers will not be used in a translation. So we can't say like total 65,000 port, 65,535 ports we have in a translation. So 0 to 1023 and few standard port numbers in between. So we exclude around 1.5 port numbers, 1.5K port numbers, right? And we get approx 64K ports available for getting translated to a single IP. So this is the way of saving the public IPs. If you guys go for a dynamic PAT, definitely you'll be saving the number of public IPs. Okay. So dynamic PAT uses a single public IP with the multiple dynamic ports to allow the private users to go outside. So this is the way we save and public IPs. Now, in a dynamic PAT, okay, in a dynamic PAT, what happens? You can see here, this is a kind of a simulation for your dynamic PAT. Before translation and after translation, what happens? You can see this is a host. While initiating the connection, it takes a random port number 26547, gets dynamically translated to a public IP, right? Same public IP over here, and it gets translated to a dynamic port number. So you can see the choice of your IP address, you have only one, but the multiple different port numbers you have. So whenever the users will try to initiate the connection with the dynamic port numbers will get translated to a single public IP. You can see translated to a single public IP, but the port numbers will change. Different port numbers will be there. So this is what we call as a dynamic PAT or the dynamic hide, or you can say hide NAT or hide PAT. Sorry, say it as a hide PAT. Okay. So this is what we do, translating a group of private addresses with a single public IP with the dynamic port numbers. This is how we save the multiple public IPs. Now we'll see the example of a static NAT. Static NAT is also known as one-to-one translation. Each private IP address is mapped with a single public IP address. It's a bidirectional. So this private IP, while getting outside, gets translated to this public IP to reach this destination. Well, the same public IP can be used to get from the outside to your private IP. This is called as a bidirectional. So it's a one-to-one translation. In a static translation, also you need to understand that we'll have an equal number of private and the public addresses required. So static NAT are used in a real time, but only in the special cases wherein you need to allow all the services. Okay. And here we have a single public IP translated for a single server. This is how it gets translated. Now, static PAT, a group of private addresses, private addresses getting mapped with your single public IP with the static port numbers. So, well, we can also use a static PAT for saving our public IPs. But in that case, we fix the destination port numbers. So always remember your destination port numbers will be fixed. In static PAT, we use a single IP address, single public IP address with the static port numbers. The port numbers will be fixed every time. IP address bound to a static port. This is what you understand. So guys, we basically understood what are the translation, how the translation works, types of translations. Now we are going to see a practical of our dynamic or the hide PAT. Okay, so we'll see how can we translate a group of private addresses with a single public IP. Now, as we had seen earlier, our topology. So I'll try a translation applying for this LAN PC. Our entire LAN hosts will get translated with the outgoing interface. My outgoing interface is 75 from the WAN subnet. All right. So my current WAN subnet is 172.16.3.0, not this one. So I'll be using the translation from the 172.16.3.0. This is an IP address. Okay. Okay. Our WAN subnet is 172.16.3.0. From this, we have .75 as a WAN IP. So I want all my LAN networks to get translated with this outgoing interface or the WAN interface IP to get an internet access. So let's get started. Now, here I'll come to a topology. In this topology, I'll come to my checkpoint firewall. In our previous video, we had seen how to configure the routes. We had got the internet access. So I'll quickly test the internet access from the checkpoint firewall. Try to ping a destination address 8.8.8. So you can see I'm able to reach outside from my firewall. From the firewall, I'm able to reach the internet. Let's come to our LAN PC and let's see, do we have an internet access? So coming to a LAN PC, if I try getting an access, let's say if I try to get an access from the LAN to 8.8.8, you see I don't have access to the outside outside world because my private IPs are not translated to a public IP. So let's do a translation. Now we'll come to our smart console to get an access to SMS so that we can deploy a translation rule. So I'll log in here. I'll say test 123, click on login. So initially while logging through a smart console, it might take some time. So it's launching application. Let's wait for a few minutes. Initially, when you'll start the smart console to connect with your SMS, it will take some time. So you have to keep patience. Okay, here we go. So you need to see your checkpoint firewall SMS all are good over here. On our checkpoint firewall, we can enable one blade that's for monitoring. So enable a monitoring blade on it. Click on OK. Now I'll come to a security policy. In a security policy, we'll see different types of policies. It's loading. Okay, here we can see we have a policy and we have a NAT policy, right? So under the access control, we have a policy, NAT policy. I can go from a NAT policy to define the policy for a translation, but the best way or the short way you can implement a translation is you can create a new policy instead of using this cleanup policy. If you want, you can add a new policy. You can do some modifications. Okay, this cleanup policy, you can use it for some other purpose, like if unwanted traffics are there, if you want to deny it, you can use it for that. with any source to any destination. Okay. If you want, you can make it as a drop as it was earlier, but make sure that you are creating different rules. Because here I'll create one rule for management before I go for LAN to WAN translation. This I'll create for management. Any source, or else I'll write the subnet over here. So I'll go for the network. In this, I'll add management subnet. And here I'll add 105.0.0.0 with subnet mask 24. Okay. And I'll click on OK. So this rule I'm creating to get an access from management to management subnet. And I want to deploy it to your firewall. So action should be allow. And log should be generated. Policy should be deployed on the firewall. Okay, action not changed. Let me modify. Accept. And this previous rule, cleanup rule, wherein everything was allowed, this I'll make it deny. So I just want to allow the limited traffics. So management to management zone, we have an access now, will not lose a connectivity to our management. I'll add one more rule. And in this rule, I'll write it down. It's between LAN to WAN. I'll add a subnet. My LAN subnet is, it's a LAN subnet. And for LAN subnet, I want to add a translation. Directly, you get the NAT option over here. And you can go with add automatic address translation rule. That's a hide NAT. And it's a hide behind the gateway. If you see this option, hide behind the gateway, you understand we are adding a translation using your outgoing interface. That's your WAN interface, right? If you want to hide behind any other public IPs, you can define that public IP over here. Okay, if you want to go for a static, you can go for a static, but if you I want to go for a dynamic, so I'll go with the hide. And I want to go with the WAN interface IP, so I'll be selecting this option, right? And I would say okay. So this is how we do our translation. Okay, IPv4 or IPv6 must be defined. So this is basically configured on a configured on your Checkpoint One firewall. So select this option. Okay, hide behind the gateway. Go for this. Come to general. Here we'll define a subnet as a 10.11.11.0 and subnet mask as a 24. So remember, for this particular subnet, I'm telling that you should get dynamically translated with the outgoing interface. That's your WAN interface, and select OK. Now I created a policy with the action as a, see, any app services applications are allowed. Action will give as a accept, allow. I need a log, and it should get deployed on the Checkpoint firewall. So this is how you can, select all the details. So now let's quickly install this policy. Let's publish and install it. And it gives you option to install the policy now. So let me click on install. And we can see this policy is getting deployed now. So we can track the deployment. A policy getting 20% complete, 40%. So it's going on. You have to wait until it gets completed 100%. So wait for a few more seconds. Let it complete 100%. Just waiting to complete 100%. This policy should get successfully deployed on your gateway 105.0.0.53. So let it complete. We're expecting it will 100% complete successfully. Here we go. So it says anti-spoofing is not configured on the interface and the gateway. This will, okay. So this didn't create an issue. I can see it was just a warning. And here we see all the policies are deployed on the firewall successfully. Now it's time for testing. Okay. You can see the 0 hit counts as of now because your request hasn't been initiated. Let's come to our LAN PC, try to reach outside. Here we go. We are getting access to our internet, and we can try reaching from our inside to any particular websites. So let the browser open. I'll try to browse any website like www.google.com. So here I get the access to our internet. Now these logs can be verified on your smart console. So I just want to refresh. Okay. So I just want to refresh the logs over here. And here we can see the logs getting generated. So you can see this log 10.11.11.6 reaching to our destination of the Facebook on the TCP port number 443. Right. Now, if you want to verify the logs, you can double click on it. And you can see the origin was, from the checkpoint one firewall, it was trying to get an access. This was a source port number with the random port number. Okay, random source port. This was the source IP, not a port number, source IP and the port number from the internal trying to reach to a destination that's your external to the port number TCP 443. Okay. And you can see in the accelerate table, this source IP, your source NAT was done. Source IP was translated to the external interface IP, that's your WAN IP 172.16.3.75, to a random port number, that's your 26677. And you can see the rule number, translation rule number. Okay. And also, if you want to see what was the rule that allowed your traffic to go from inside to outside, the rule name was LAN to WAN and number was 2. So this is how you can verify the log. So this is the rule number 2, LAN to WAN, which allowed your traffic to reach outside, right? And this is the log which you can see wherein what was the source IP, source port number, destination IP, destination port number, and the translated IP and the translated port number, and through which rule it got masked and got allowed, it can be easily seen over here. So guys, this was your Hide NAT. Hope you guys enjoyed our video. See you guys in the next video with the next concept. Thank you.